All right, so we are going to wrap up Unit 4 with our final lesson today, and this really is, in most ways, a very comprehensive review, right? Because you have to be able to graph your linear functions, your absolute value functions, right? Your quadratic functions. You have to be able to find those points of intersection, and you have to be able to verify them. All right, so you can see that we take in 3 of our topics out of our 4, all right, for this particular standard just in this one lesson. So the good news is if you've been working hard, all right, and you've learned the material, all right, this lesson should really click for you. The other piece of good news is if you were a little uncertain of things, right, this is kind of a nice way to kind of polish some things, all right, and get you to a good place of understanding. All right, so we're just going to jump in. All right, there's no opener today, right? We're just going to jump right in, all right, and get to the work. So, all right, so we are going to, all right, graph our systems of equations, all right, and we're going to find our point of intersection or intersections, all right, if they exist, and then we'll verify them. Now, remember, the first thing that you always want to do is identify what type of function you have. All right, so when I look at my first equation here, all right, I know it's linear. There's no exponents. All right, there are no absolute value bars. So I know this is linear. Now, for this particular linear function, my starting point would be 0, 2. All right, so I start at 0, 2, which is right here. And then my slope is negative 2 over 1. And so from this starting point, I'm going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Now, once again, since we're looking for points of intersection, I might do a few more points than normal just to try to be a little bit more accurate. So now I'm going to go up 2 to the left 1, up 2 to the left 1, all right, just to generate, all right, that line. And then we're just going to very quickly, all right, draw our line in just like that. All right, now move to the second equation and you just repeat the process. Identify the function, all right, then use what you know to graph that function. So when I look at our function here, once again, I know it's linear, all right? There's no exponents, all right? There are no absolute value bars. Now, this is a specific type of linear function. Now, the x and the y are on the same side, so this is standard form. Remember what we said when we do standard form is that we want to find the x and the y-intercept, graph those 2 points, all right, and then draw our line. So now when I do my x-intercept, I know y is 0. So 16x plus 8 times 0 equals 16. So 16x equals 16. So 16 times what is 16? And that would be 1. So my x-intercept, all right, would be 1, 0. Oh, and look at that. That's on the line we already graphed. But we want to keep going, right? So now let's find our y-intercept. So we know x is 0 when we find the y-intercept. All right, 16 times 0 is 0. That leaves me 8y equals to 16. Now 8 times what is 16? And that would be 2. So that means my y-intercept is 0, 2, which would be right here. So I get the same x and y-intercept. And I would just draw the same line. So now, system of equations. If I have the same graph on top of itself, all right, remember that means that we have infinitely many solutions. And when we have infinitely many solutions, if you can read that, all right, we do not have to do any verifying here. So we get to skip that step. So that's kind of a nice thing about getting an infinitely many solution problem. All right, so we don't have to verify anything, get the same graph. All right, now let's move down to number 2 here. All right, so now, once again, start by identifying the type of function, right? So make sure you know those telltale signs of each function. So notice what stands out about this particular function. We see the bars, right? Those are absolute value bars. So this is an absolute value graph. So we know it should look like a V before we begin. And then we begin with identifying the vertex. And so it is negative 1, 4, all right, is my vertex. So negative 1, positive 4. Now my A value is negative 2 over 1. All right, so from my vertex, I'm going to go down 2 to the right one, down 2 to the left one to create my V, just like that. And I'm going to repeat that, right, a couple more times on each side. All right, once again, we are looking for points of intersection, so we might graph a few more points, all right, than we would if we were just sketching a graph by itself. And then let me draw that in. And I'd also advise, like using a ruler for your absolute value and your linear graphs, all right? It just makes it a little bit cleaner, all right? It's gonna help you see those points of intersection a little bit better, perhaps. All right, now, have that graph. Now let's move on to the second part of our system here. And once again, I'm gonna identify what type of function do I have. No exponents, no bars, all right? So this is a linear function, all right? So now I need to find my starting point. And my starting point for this linear function is negative 4, 5. So negative 4, and 5 is right there. So I'm going to start right there. And then my slope is negative 1 over 3. So from that, remember, slope is rise over run. I'm going to go down 1 to the right 3, down 1 to the right 3. And notice what happens. Down 1 to the right 3, I hit that vertex. I go down 1 to the right 3, and I keep going. Now, since I see the point of intersection and I see that there are no other points of intersection going to occur, I can stop at 3 points. So there we go. So here's what we see, right? We have a line and an absolute value function. They intersect once, and they intersect at the point negative 1, 4. All right, so now we want to verify. Now, what this really is doing, right, it's really serving a couple different purposes. So one, it's a built-in self-check, because if this is the solution, if this really is a point of intersection, it should make both equations true, right? So we're kind of forcing you to, all right, self-check your work by asking you to do this. The second thing is we're also, all right, keeping you working with your order of operation skills, all right, and keeping those fresh as you work. So remember to verify. This is your x value, this is your y value. So when we look at our equations, and I'm just going to rewrite them both right here. All right, we're going to take the y value, plug it in for y, take the x value, plug it in for x, and hopefully we get 2 true statements. All right, so 4 is y, and negative 1 is x. So I'm going to plug that in. And so notice inside of our absolute value bars, we get 0. So we always do those grouping symbols first. Then we have to take the absolute value of the number before we do any other operations with that number. And the absolute value of 0 is 0. And then negative 2 times 0 is my next operation I perform, because it comes before addition. So that's 0. And then 0 plus 4 is 4. So it is verified, right? So I should get a true statement, all right, at the end. Now let's repeat the process, all right, for our second equation. So once again, y is 4 and x is negative 1, just like that. And once again, we start inside those grouping symbols, right? So negative 1 plus 4 would be 3. All right, then I do the multiplication. So negative 1/3 times 3 is negative 1, and then plus 5. And then negative 1 plus 5 is 4. So notice, all right, it is verified. I get 2 true statements. So I know for sure my work is correct. All right, let's flip the page and let's look at problem 3. Look at problem 3. Okay, now, once again, if I'm going too fast, you need to recover a little bit. Pause the video, finish your work, all right? If you think you have something that doesn't really make sense, pause the video, circle it, highlight it, all right? Make sure you, all right, are ready and prepared with those kind of things when you come to class. Now, once again, same process. First thing, identify the type of function you have. So when I look at this, there are no exponents, there are no bars. This is a linear function. So my starting point for this linear function would be 0, negative 6. So I'm going to start at 0, negative 6 right down here. All right, and then my slope is 2 over 1. So up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And once again, just drawing in a few extra points because we don't really know where things are going to intersect. So we want to be as accurate as possible. All right, and there's our line. Okay, now moving on to our second function here. Now what I see is an exponent. Okay, we have 2 functions that have an exponent. We have quadratic and exponential. If the exponent is a 2, it is a quadratic, and we should know that our graph will look like a U. If the x is the exponent, we know it's exponential. All right, so this is a quadratic. And once again, just like with absolute value, we start the graph of a quadratic with, all right, its vertex or turning point. So in this case, that would be 1, negative 8. Okay, so 1, negative 8 would be right here. Okay, now remember we graph a quadratic. We get our first pair of points after the vertex using our a value. So in this case, our a value is 2 over 1. So from my vertex, I'm going to go up 2 to the right 1. I'm going to go up 2 to the left 1. And I can see I already found 1 point of intersection there. All right, but it looks like if I sketch this graph, I might get another point of intersection. So now we want to do 3a. All right, so 3 times 2 would be 6 over 1. So now I'm going to go up 1, 2, 3, 4, 5, 6. And there I get a second point of intersection. From this point, I go up 1, 2, 3, 4, 5, 6, and to the left 1. All right, and I can see that if I draw my quadratic in here, there's the first point of intersection, and there's our second point of intersection. All right. Okay, so we get 2 points of intersection. The first is 0, negative 6. The second, all right, is 3, 0. Now, once again, let's verify those. Now, remember, right, I'm going to just rewrite my equations here. we have 2 points of intersection. So I'm going to have to do this process twice. I'm going to do it first with 0, 6, and I'll repeat the process with 3, 0. Remember, this is your x, this is your y. So if I take -6 and plug it in for y right there, and then 0 for x, I get that. 2 times 0 is 0. 0 minus 6 is -6. So it verified on the first one. Now I'm going to take 0, -6, and I'm going to plug it into this equation. So y is -6, x is 0. We're going to go through our order of operations. So once again, start in those grouping symbols. So 0 minus 1 is -1. Okay, now remember, -1 squared is -1 times -1. So a negative times negative is a positive, and then 1 times 1 is 1. 2 times 1 is 2, and then 2 minus 8 is -6. All right, so that's verified. So we know for sure that we are good on 0, -6. Now, we just have to repeat that process with 3, 0. All right, so once again, there's x, here's y. Now I'm going to put 0 in for y and 3 in for x. All right, and then once again, 2 times 3, 6. 6 minus 6 is 0, so I get 0 equals 0. That's verified. All right, so y is 0, x is 3. Okay. All right, so there we go. Oh, I miswrote the problem here. That should be a 2 on the outside. So that's 2 on the outside. All right, so once again, starting in those grouping symbols, 3 minus 1 is 2. All right, 2 squared is 2 times 2. So 2 times 2 is 4. All right, 2 times 4 is 8. And 8 minus 8 is 0. All right, so it's all good. So that means my graph was good. I have the right points of intersection, so all is well. Okay, so once again, built-in self-check. All right, you should know if you have done the problem correctly if you verify. All right, one more problem here. So let's look at problem 4. So once again, starting with identifying the type of function we have. Okay, no exponents, no bars, linear function. So I'm going to find my starting point first. So my starting point this time is 0, -8. So that would be way down here. My slope is -6 over 1. And so normally I would go down 6 to the right one, but I run out of room. So now I have to reverse it, all right, from the very beginning. So now I'm going to go up 1, 2, 3, 4, 5, 6, and to the left one. I'm going to repeat that, 1, 2, 3, 4, 5, 6 to the left one, just like that. All right, I might be able to get one more point, 1, 2, 3, 4, 5, 6, and get that one more point up there. All right, so remember, you should know that if you have a negative slope, right, your line should be going down a hill from left to right. Okay, so there's my first line. Now, let's look at our second equation here. All right, once again, no exponents, no bars. I know it is a line. All right, start with our starting point. In this case, it would be 0, 2. So remember, anytime we don't have those parentheses, right, we know the x value is going to be 0. Okay, so I'm going to start right here. Now notice I have the same slope here. All right, -6 over 1. And if I go down 1, 2, 3, 4, 5, 6 to the right one, all right, 1, 2, 3, 4, 5, 6 to the right one, I get my second line. And there we go. And notice what we get this time. We get no solution. We get parallel lines. All right, when we know parallel lines will not intersect. And now, so once again, why did we do some parallel line work in our previous lesson, right? Or excuse me, our previous unit, right? It was so that to prep you for this kind of situation, right? And some of you might have already been anticipating that because we talked about if lines have the same slope and different y-intercepts are going to be parallel, therefore they won't intersect. Therefore, there's no solution. And that also means we do not have to verify anything. All right, so with infinitely many solutions and no solution, there's no verification process. All right, my friends, that wraps up, all right, this part of the video. So once again, questions, things that don't really click for you, make sure you have those highlighted, written down, okay? Share those when we come into class, and then we'll wrap this up, all right, which also wraps up our final, our last bit of this unit, all right, and then we'll move into our review next time. All right, see you guys in class.